Alright, so this circuit should look familiar to you. This is simply just a blinking light that's coming off pin 10. So the instructions are there, come out in pin 10. On pin 10 make it high, wait quarter of a second, then make it low, wait quarter of a second, and put in infinite loop. Sometimes we don't want things to be in an infinite loop, so we're going to put in a for statement. So let's do something while a condition is being met. For this to actually work, I'm going to set up some variables. So I'm going to make an integer, and we'll call it I, which is short for increment, which is very popular in assembly language, and I'm just going to set that for 0 at the moment. And I'm going to make another variable called count, and I'm going to make that equal to 3. So I want this to do something 3 times. So I'm going to use the for statement. For I is equal to 0. I want it to keep on doing something while it's less than the count. I'll just put in some spaces so it looks a bit more prettier. Now, because we're actually doing an increment, we need to actually tell it to increase. So an old-fashioned way is actually saying I, the increment, is equal to the increment plus 1. However, under C you can take a shortcut and just do plus plus because it's used all the time. Alright, curly bracket. So inside of this in here is going to be repeated for how many counts we have, and then we're going to use the end curly bracket. And so we know that something has occurred, we're going to put in a delay here of 2000 milliseconds. Alright, let's start the code, and it switches off. 1, 2, 3, and off for 2 seconds. 1, 2, 3, off for 2 seconds. If I go back into my code and change it to, I won't put 35 because that will take too long. I'll make it 10. We'll start our simulation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and off for 2 seconds. So we've actually got that looping around. Alright, let's go into the real life. By doing that, we're going to copy our code. Select everything and override it. Make sure that last bracket, sometimes it's missed when you copy and paste for some reason. Just going to do a quick verification. I don't want to save it. And it should be fine because we actually did it in simulation. Now I'm just going to bring in my breadboard. Now I'm not using an Arduino Uno today, but it doesn't make any difference. So on the Pro Micro you can actually see pin 10 is hooked up to the LED, then there's a resistor, and that resistor is then connected to ground. Alright, so if I then upload my code here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and off for 2 seconds. Alright, so just showing you the for statement there. Okay, so now that we've got that working, we're going to use the serial command. So this is a way for your device to communicate with another device. In this case, we're going to use it with a computer. Alright, so let's change our code here we need to set up a serial port. So we have serial. So serial being ones and zeros sent one after each other. And we want it to begin. And a nice default value is a baud rate. So how many data bits sent per unit time. Okay. So we're going to use it simply just to give us a bit of a diagnostic tool. So I'm going to type serial.print line, the value of I. So I want to observe what's actually happening in my circuit. And we can do that using the serial monitor down here. When we finish the 3 flashing lights, I want it to tell us that we've actually exited the for statement, and I know my code is following on. Okay, so out of the for loop. That's going to come up here. Now I'm just going to change that just to a print, so that will just print the numbers one after each other. Alright, so let's start the simulation here. I may change this down to just only 5 blinks, otherwise you're going to get bored. So you can see it counting to 5 there. Remember 0 is a value, and now it's out of the loop. So you can actually use this to report the data, but also in future and more advanced work you can then send it to another device. So let's say temperature readings to a computer, and then for post-processing. Okay, so that's how we can actually get data out of our program. I'll stop the simulation now, and we'll upload it into the real world. So I'm going to copy that, go over to Arduino, and as you see I've just wiped everything. I'll paste it in. Let's bring our Arduino that's actually hiding in the corner. Now that's still happily running away on the previous program. I'll just make it a bit smaller. Alrighty. So let's actually upload this. I don't want to save it at the moment. It's compiling the sketch. You can see the transfer as it's programming. And I know it's working because now it's only flashing 5 times and then taking that 2-second break. But how do we actually see the serial output? Because we haven't hooked up an LCD display yet or anything. So what we do is we go down to the serial monitor, and you can see these are the values that are coming out and back into the computer. So this is not part of the simulation, it's actually coming from the Arduino itself. So we can actually send text. Alright, so we successfully controlled, well, we can actually see what's happening inside of the program using the serial monitor as a diagnostic tool. But let's make it a bit more interactive. Wouldn't it be nice if I just said, hey, I'll type in a 6 and it blinks 6 times. So rather than a serial output, we're going to use a serial input. And if you can see down here, I can actually put in values there. So let's clear this for the time being, and we're going to use the serial input. So for starters, we need to make sure that we've actually got some data in the first place. So we're going to use the if command. If the serial is available, so there's no conditions on that one. So if it's bigger than 0, which means, yep, I've actually got some data, I want you to do something. Alright. Now this counts is the value we want to get from our little text box in here. So the count is going to be equal to the serial, be nice if I spelled it correctly, the serial, and we're going to use this command called parseint. So when we get a value, it normally is recognized as a byte. So if I type the number 3, it actually reads what the ASCII character is for the number 3. But what we want to do is actually pass that integer value. So we're pushing it in that way. Now, just for a bit of fun, and also diagnostics, so serial.print what my count is. Alright, so we're no longer using the number up here, so I'm just going to define an integer called count. If a serial port is available, pass that value into count and print it off, and then count is going to be the condition of how many times it flashes. Now I've got a bracket there, so then I need another bracket here. So let's see how this goes. Now, have I put all my semicolons in? Yes. Alright, so let's go have a look at this, and all I've simply done is a spelling error there. So let's start the simulation again. I've plugged it in, and as you can see, there's no LED light here. So what we need to do, as you can see, it's saying it's out of the loop, out of the loop, out of the loop every 2 seconds, because it's actually skipping over all this code because there's no serial input. Now if I go into here and actually type 3, did you see that? So I'll type 5 this time. I might just modify the code so we can actually see the number that we input. We'll clear this again. So it's going out of the loop, it's not doing anything. If I put in a 5, it prints the number 5, it flashes 5 times, and then it's out of the loop. If I put in 3, it will flash 3 times, and then say out of the loop. Remember, 0 is actually a value, so therefore 1, 2, 3 values. Alright. So let's see how this works in the real world. So I'm going to copy all my code here, and I'll stop it. Go over to my Arduino and simply paste in my code. I'll bring back my breadboard. Here we are. So we can actually see the real world. Just line it up a bit nicer and upload the code. I don't want to save it for now. Alright, so the light has switched off. These are your receiving and transmitting ones. So when we actually put in numbers, you'll actually see these flash because we're actually doing communications. So we'll open up the serial monitor. So that should be saying, yep, it's out of the loop, it's out of the loop. So if I type in 4 flashes, so you can actually see the transmission of the data. So that's transmitting, and every time it's transmitting, you can see the out loop there. So if I type in 10 now, it will count 10 times, and then it's out of the loop. I'm not sure about this 0 artifact. Haven't been able to work out why it's doing that, but it's not interfering with our code too much at the moment. And one more try. Let's go for 3, and that's it. Alright, thanks guys.